Hi, mathematicians. We are looking at linear function pattern recognition. We're going to do some more examples with that. Again, this is linear functions from a table of values, and we are specifically looking at when x values change by different values. We're going to continue to identify the rate of change for these linear functions from a table and focus on the unit rate when given a change in x that's other than 1. At the top of the second page of your guided notes and practice packet, you'll see 3 more examples in the whole class section. We're still going to be looking at tables and identifying rate of change, including unit rate, and identifying the function type. So looking at question 4 right here, we have x values and y values. We are still needing to find the rate of change. I'm going to write our formula for rate of change. I like to have that at the top of every page to help us remember that. So rate of change in y over change of x. And for each one of these tables, we're going to need to find the change in x and the change in y. So as we look at the change from -1 to 1, you can visualize this or you can put it on the number line. If I'm starting at -1 and I'm going to +1, I'm going to the right. That's an increase. So it's adding 2 units. And you can see that there. Now let's take a look. We have 7.5 to 6.5. So you might just see right away that you notice that is decreasing. You can also look and put that on a number line. So 7.5 would be between 7 and 8. And 6.5 would be between 6 and 7. And you're going from 7.5 to 6.5. So you're going to the left. Again, that's decreasing. And even though they're fractional, you're going to the same point. You're actually just decreasing by 1 unit. And that's what you want to think about there. Complete the rest of these changes down your table. So here you can see all of the x values are increasing by 2. All of the y values are decreasing by 1. This tells us every 2 that the x increases, the y is going to decrease by 1. And that's constant. It's the same throughout the whole table. So we can say that our rate of change is constant. We just have one rate of change for the whole table. And it is change in y, which is -1, over the change in x, which is 2. So this makes it a little bit, it looks a little different than what we've done before. We want this to be something over 1 for our unit rate. And our fraction can't be reduced. It's -1 over 2. But you could divide this out or recognize it as a decimal. So it is equivalent to say that for every 1 change in x, the y is going to decrease by decrease by 1/2 or -1/2, which can be written as a decimal, which is how I usually think of it in my rate of change. So -1/2 over 1 is our unit rate. And you can do that. If it wasn't a decimal you recognize, you would just divide that on the calculator, -1 divided by 2, and get that decimal equivalent. And of course, anytime we see the word constant, we know that we have a linear function. Taking a look at example 5, again, always want to do change in x and change in y. And that is what you're going to do here. And again, if it's helpful for you to look at the number line from -6 going to +2 over here, you are going to the right again, so this is increasing, and you can count those spaces. You're increasing by 8. For change in y, you're looking at 45 to -19. On this number line, we don't see those numbers, but we can imagine where they are. So here's 0 for context. 45 would be somewhere way over here, and -19 would be just out of the frame here. But you are going from 45 past 0 and then all the way to -19. So there would be 45 units here and 19 units there. And so you're going to add up all those spaces. I mean, you could count them, but you don't want to count that far, I don't think. And you can see that 45 and 19 are add to be 64. And because you're going to the left, or you can see in your table you're decreasing, that is going to be negative 64. Please complete the rest of your changes. You can see that our change in x increased by 8. All of our x's increased by 8. And all of the y values decreased by 64. So we just have one rate. It was the same for the whole table. That means that it is constant. And that's going to be a constant rate of change of negative 64 over 8 for our change in x. Our change in y over our change in x. And for our unit rate, you can divide this on your calculator. Negative 64 divided by 8 comes out evenly. And our unit rate is going to be negative 8 over 1. And of course, every time we see the word constant, we know this is a linear function. For question 6, you are going to do your change in x and your change in y. Please calculate those now. You can see for the x's, I was at negative 4 and I went to 2. That's to the right 2, and you can keep following on your number line that was all increasing by 2 down our table. For y's, negative 4 to negative 3 is an increase of 1, and if you follow that down your table, they were all increases by 1. Our rate of change, because these were all the same, is again constant. Anytime it's constant, we know that it's linear. And our rate of change is always the change in y, which is positive 1, over the change in x, which is 2. And again, this is a reduced fraction, but to make it a unit rate, we need it something over 1. So 1 divided by 2 is 0.5, 0.5, or 5/10. And so you are just going to write 0.5 is your numerator. So this tells me that the original rate of change for every increase in y by 1, your x is increasing by 2. It's equivalent to say when your y increases by half, your x increases by 1. Just a quick summary on this slide. This is not on your notes, but just to make sure you've gotten the big ideas from today. Our rate of change, this is not going away. You're going to need to know that it's the change in y over the change in x. All linear functions have a constant rate of change. The constant rate of change means that the unit rate is the same for the whole table. And how we calculated unit rate today, unit rate is always something over 1, and that something is when you divide your rate of change. So the change in y over the change in x over 1. That ends up being what your change in y is. And you can ask yourself, what is the change in y when the change in x is 1?